we don't just need like our eyes to see things around us. Like I can see that book with my eyes, but without light I can't. That's what we've been talking about today. So what is exactly light? It's like a property in physics that helps you see things around you. We have to see the world around us with light. We can't just use our eyes. Light from any source, let's say the sun, a candle, an LED light, the light rays, it goes on that object and then like bounces back, and that reaches our eyes, and that's how we are able to see a lot of things. But there are many sources of light, mainly two types, artificial and natural sources of light. So what are natural sources of light? Sources of light that are able to emit light on their own. They have their own light source inside them. And artificial sources of light are those which need a source of light to emit light. So like a candle. So there's a wax kind of candle kind of bar, and there's a little stick, and you light the candle up, and the fire is itself, it's a natural source, but the candle hole itself, it's artificial. That's where it's been emitted. But natural sources of light are like the whole thing. It's like the sun, the stars. But you may believe it or not, the moon is an artificial source of light. It just bounces back light from the sun and it just reaches us. So it reflects it as moonlight. So it's a non-luminous object. I wouldn't say artificial. There are a bunch of sources of light too, and that lies in the category of luminous objects. Objects that can emit light on their own. But artificial sources of light, they cannot. They need a source of light to power them up and see everything around us. Now, what are non-luminous objects? Objects that cannot emit light on their own. They actually bounce light from like a source, and then it just enters our eyes. The same way how we see books. Books like this, it's like a mirror. It reflects light from wherever and then reaches our eyes. That's where we'll be able to see it. Now, we have to come that light passes through like many mediums. It can travel through vacuum. Vacuum's like there's nothing in it. There's no air, there's no nothing. We can't live there. But that's not where sound can travel. Light can only travel there. That's cool. Now, there are three kinds of sources, three kinds of materials that light can pass through. Transparent, like glass. Translucent, like frosted glass, or like foggy glass, or like butter paper. And opaque objects where light cannot pass through it. It has to bounce back. So transparent objects like glass, they can help light pass through easily, no problem at all. But translucent, partial, like light can pass through it partially, some cannot. But opaque objects, light's just gonna bounce back. It just doesn't go through it. Light travels in many ways too, but it can only travel in a straight line. So that's called the rectilinear propagation of light. So it can only travel in a straight line. But if it were able to bend, it would just find a way around, but that doesn't happen. Now, there are three kinds of, light rays? Yeah, there's like a beam, which is a collection of light rays that travel in a straight line. And there are three kinds of them. There is, of course, parallel beams of light. So let's take the sun. It's 1,500 lakh kilometers away from the earth. It shines rays of light in a beam. But since it's so far away, they kind of spread out to be parallel, not like go everywhere. That's called divergent beams of light. Like light from a point source, it just scatters around, for example, an LED light or the light just above me, shining on the light like a spotlight. And a convergent beam of light is literally the opposite of divergent. Light from all around the world come and convert into like a tiny point. Pretty cool. And light travels 3 lakh kilometers per second. Still takes 8 minutes to reach Earth from the sun, and in Saturn it takes 1 hour. Light also helps making pinhole cameras. Now, what are pinhole cameras? It's like a device used to take photographs with the camera. So like there's a tiny box, and with a tiny hole just screwed into it, a hole where light passes through, and on the other side there's like grease or butter or cellophane paper. Let's take a source or an object or whatever that is. Like let's take a candle. So a candle and like the pinhole camera and the pinhole right here. So there are many rays like reflecting or from that candle light. Two light rays, A and B, the one like just one from the tip of the fire thing and like from the bottom, and A travels in like a slanting place. So let's take the pinhole as H. So it'll pass through pinhole H in the line AH and go to the other side where B is like literally parallel to it, and B will go to the other side where A is there, and where we end up is A1 and B1. A1 is literally here, B1 is literally here. Yeah, so real images like this are inverted, but virtual images in the pinhole camera, they're not inverted because they're virtual. And all the rays between A and B, like C, D, E, F, G, I, H, I, J, whatever, they will form the image of an inverted form of that candle. And funny thing is that if you move the greased paper or whatever surface it's going on to form the image, if you put it closer, like this much, it'll become much smaller, the image, but also much more clearer, and you can see the colors. But if you go far away, then it'll be bigger but blurrier. Okay, now we're going to be talking about shadows. So we have a shadow, like we see it every day. If you're going on golf or football, you're always going to see a shadow tied to you. So how are shadows formed? Well, we're opaque materials or opaque living things. Yeah, we're opaque living things. And when light passes through us, of course, we block the light. We're being shined on or shown on, and that way we can see ourselves, but light will bounce back. And that kind of block of light, it'll resemble our like human kind of form and form a very dark, almost black screen, kind of grayish too, on the ground or any sort of screen. So let's take my hand. There's a light source over here. So when the light source comes here, it bounces back. But since it's bouncing back, it can only go in this kind of area since there's no light. Light can get passed through. But the spot where we cannot see the light, it bounced back, it'll form like a screen, like somewhere over wherever the screen is, like an opaque object, and that will form a shadow. So it needs three things: a light source, an opaque object, and a screen, which can be anything but not transparent materials or translucent, only opaque. And there are some properties of shadows. So we can take a hand, but sometimes if we tilt the light source somewhere here, it's only going to reflect a part of the opaque object. It's two-dimensional, of course, not three-dimensional. And now we come to shadows. Well, you can't just put a shadow like there, like I said, you can't put shadows in like a transparent or translucent object, since that won't like form the shadow. So if we like just put our hand and a light source and then there's just open air in the window, it will not show the shadow because it's an opaque object. It's not an opaque object, it's transparent, translucent or whatever. So now we're going to be going to the size of the shadow. So it depends on the light source and the object and the screen. So if the object is far away from the screen but closer to the light source, since it's being blocked really closely, the rays, it'll go so big that it will only resemble like a very big part of, it's like a very, very big part or very big shadow of your hand or whatever. And if you bring it closer, or like closer to the screen but away from the light source will still shine on it, but it'll become much smaller, but also much clearer. There are two regions of the shadow too, an umbra and a penumbra. An umbra is like the very, really dark black region of the shadow, almost black, and the penumbra is like a ring around the umbra, and it's like grayish. It's gray because like there's a little light, but still getting the darkness from that umbra thing, the shadow. So there are some properties of that umbra and penumbra. Let's take a ball and like a really small, kind of almost point source of light. So if we take a ball and a point source, it's going to become, the umbra is going to become very big since it's a point source, but the penumbra is also, it's going to be very small. And if you move the screen away much more, the umbra will become even bigger, and the penumbra may not even show. But if you do the exact opposite, the light source is big, and we have like a really tiny kind of a ball or whatever, and have a screen. If it's close to the screen, the penumbra will be very big, but the umbra will be like almost a finger or something like that. But if we move it even farther away, it comes to such a point that we don't even see the umbra. There's like a penumbra. Okay, now we're going to be talking about the eclipses. You've always seen like those things like, what is an eclipse? What is that? That sounds so interesting. Yeah, okay. So there are two types of eclipses, a solar eclipse and a lunar eclipse. Yes, this happens in space. So an eclipse happens when the sun, the earth and the moon are revolving. The moon revolves around the earth revolves around the sun. But it comes to a point that the sun, earth and moon, they're in a straight line. They're in the same plane, straight line. And that's when we form an eclipse. So it's either the earth in front of the moon or the moon in front of the earth. And the earth or moon will cast a shadow on the other thing, but not the sun, of course. The sun is the light source. So if the earth is in front of the moon, you'll get a lunar eclipse. A lunar meaning you can't see the moon if it's in the umbra region of the earth. You can't see the moon if it's right at the center. But if it slowly moves here, it's entering the penumbra region. Some part of it you can see. And it fully comes out, you get a full moon. So that's actually how the moon cycle works. So if it goes here, full moon, half moon, no moon, actually, or new moon day, also kind of moon day, and then full moon day. So that's how the lunar kind of cycle works, yeah. But a solar eclipse is when the moon is in front of the earth. But since the moon is really small, it only casts a very tiny shadow on the umbra region of the earth, and penumbra is just, yeah. Only a part of the earth gets that thing, so when the umbra region is like on the earth, that's when you receive a total solar eclipse. Same with the moon. If the moon's in the umbra region, that's a total lunar eclipse. But the part of the earth receiving the penumbra region, that's partial solar eclipse. But if the moon is in the penumbra region, that's a partial lunar eclipse. And on and on. And we're done with physics. Oof, that was like a really big chapter for me. And it's just me signing off.